So in this video, I will discuss about Reimer Tiemann reaction. So it is a reaction of phenols. So basically phenol when treated with chloroform and NaOH. So chloroform when treated with chloroform in the presence of a base NaOH, it gives a compound called salicylaldehyde. And this compound is also called as, if you take this OH, it will be benzaldehyde. So OH you can take it as a substitute at the ortho position. So it can be also called as orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. When you take this carbon so if this carbon is the functional group, so this carbon will be the first carbon, this will be the second carbon. So this will be carbon number 1 and this will be carbon number 2. So we can also call it as 2-hydroxybenzaldehyde. So phenols, when treated with chloroform in the presence of a base, it gives salicylaldehyde or orthohydroxybenzaldehyde or 2-hydroxybenzaldehyde, and this reaction is known as Reimer Tiemann reaction. Next, let us move to the mechanism. So coming to the mechanism part, first step is I will write phenol with NaOH. So phenol with NaOH. So I'll be making 3 steps here. So the first step will be like phenol with NaOH. So let us take the phenol now. So phenol when treated with the base NaOH. And here we know that we got the OH as OH minus. So what it will do, it will take on H plus from here. So the resulting product will be O minus plus H2O. This H will be reacting with the OH minus to give the water molecule. So whenever I write this minus like that, it shows that it has got 2 electrons. It has got 2 electrons. The minus will. Now, due to resonance in the sense, what happens is these 2 electrons, the 2 electrons which are present in this oxygen, they can form a bond here. So when that happens, what happens? I will write the structure like this. The 2 electrons which are with the oxygen, already a bond is there, a single bond is there. Again, with the help of these 2 electrons, the oxygen will form a bond with the carbon. So a double bond will be formed. Now we know that carbon valency is 4. So already for this carbon it is 1, 2, 3 and 4. So it can't have the double bond here. So what happens? So this double bond cannot be there. It must be a single bond. So basically what happens? These 2 electrons should be shifted here or the negative charge will be shifted here. So I can write the minus here to this carbon now. So no more double bond because the 2 in this bond actually 2 electrons are there. See, oxygen has got a single bond here. With the help of these 2 electrons, it has formed a double bond. Now this can't have a double bond because already the balance is 1, 2, 3 and 4. So this bond has got 2 electrons, so that will be here. The 2 electrons I will mention here. So this is what happens here now. Okay, so when I treat phenol with NaOH, this H plus and the OH minus will form water molecule. So oxygen will be having the negative sign. We know that oxygen is minus, hydrogen is plus. H plus will react with OH minus to form the water. So O minus is there, it is like 2 electrons. Now what happens? These 2 electrons will form a bond. Oxygen has got the 2 electrons, it will form one more bond with the carbon. So after the double bond formation takes place, check this carbon. The valence is already 1, 2, 3 and 4. It cannot have this double bond. So this double bond has got 2 electrons. So that I am showing here. The 2 electrons are the negative sign. So this I will take as product 1. So now the second step will be chloroform with NaOH. So chloroform, I can write the structure like C, H, and the Cl, Cl and the Cl. So when this is treated with the base NaOH, so we know that what happens is OH is minus here. So what happens? Here actually 2 electrons are there. This hydrogen will leave, in this bond 2 electrons are present. Hydrogen without taking an electron, it moves in the form of H plus and forms the water molecule here. So only the H plus from here, it will move all the way. So what does it mean? When the hydrogen is moving as H plus means the 2 electrons which are present in the bond, it will be with the carbon. So now I will write C, Cl, Cl and the Cl, and still the carbon has got the 2 electrons here. So confirming the 2 electrons. Now simultaneously what happens is, one of the chlorines, because here also we have got 2 electrons, a bond is equal to 2 electrons, this chlorine will take both electrons and it will move away as Cl minus. So minus Cl minus will write. So one chlorine will move away from this carbon, taking both the electrons which are present in this bond. So finally what will happen to the carbon now? I can write only Cl here. Here no electrons because both electrons it has been taken by the chlorine. Then once again I will write a Cl here and these 2 electrons are still there. So this compound is very, very important. We call it as dichlorocarbene. This compound called as dichlorocarbene. So dichlorocarbene, because carbon it is electron deficient. Why it's electron deficient means in this bond 2 electrons are present, in this bond 2 electrons are present, here also 2, totally 6 are there. So to achieve the octet it needs 8 electrons. So that's the reason this dichlorocarbene, to achieve octet, it needs 2 more electrons. It needs 2 electrons. So it acts as an electrophile. Here. It needs, so it can move towards the electrons. So there is no positive charge. That's the reason we call it as a neutral electrophile. So this is the carbene. Now the final step will be addition of carbene. The addition of dichlorocarbene, that is CCl2 to the product 1, what I mentioned there. So the product 1 is we have the double bond O and we had a negative sign, this carbon. So here what happens is carbon is already having 2 electrons here and I got a Cl and I got a Cl. Now this minus, I told you it is equal to 2 electrons. Now what happens, this carbon has got 2 electrons. With help of these 2 electrons, a bond will be found between this carbon and this carbon. So the answer will be like this. Still I will write the double bond O, no changes here. This bond I will write, this bond also write as it is. Now what happens is, here it's carbon. So with help of these 2 electrons, a bond between carbon and this carbon will be formed. So we are not using these 2 electrons. So they remain as such. For the formation of carbon and carbon bond, we are using these 2 electrons. Okay. So now still the Cl is here and the Cl is here. And as I told you, in benzene, each and every point has got a carbon and a hydrogen. So to mention here, this point has got a carbon and a hydrogen. So I will also represent the hydrogen here. So now what happens is, to retain the aromatic character. To retain the aromatic character means you must have alternative single and double bonds. So the ring will try to get back the aromatic character. Means you must have that 3 double bonds here like that. Now what happens in this case is, so between the carbon and hydrogen, we are having 2 electrons, because any bond, a bond between carbon and hydrogen, any bond has got 2 electrons. Here what happens, hydrogen will come out as H plus. So when hydrogen has come out as H plus, these 2 electrons are still remaining. So this carbon has got 2 electrons. So basically what happens here is, the moment the hydrogen moves away, this carbon has got 2 electrons. it will form once again a bond with this carbon. So it will be a double bond. Now naturally oxygen cannot have the double bond. So it will be once again the O minus. Then what will happen to the H now? This carbon has got 2 electrons. It can happily form a bond with this hydrogen. Because for bond formation we need 2 electrons. Even though H plus has got no electrons, this carbon can use the 2 electrons to form the bond between carbon and hydrogen. So a bond will form like CH and the Cl and the Cl. So finally this product we are treating with sodium hydroxide once again 2NaOH. So what happens is the Cl will be replaced by the OH groups. So I'll be having this compound O minus, and here it will be CH and the OH and the OH. So 2 NaCl will come out. So it is like the 2 chlorines will form with sodium chloride, and I'll bring the OH. Now whenever 2 OH groups are attached to the same carbon, it is unstable and there will be elimination of water molecule. So whenever 2 OH groups are attached to the same carbon atom, then it is unstable, there will be elimination of water molecule. So because of the unstable conditions, when 2 OH groups are attached to the same carbon. So now what happens now finally, I'll be getting this product O minus, then I'll be having the CH. OH is removed, H is removed, so naturally it will be a double bond O. And the last step will be protonation. So what you get here now, the product will be OH and here it will be CHO. So which is your salicyl aldehyde. And this is the mechanism of Reimer Tiemann reaction.